upper bound. So the least upper bound will be less than or equal to, we should not say strictly less than or equal to, this is less than or equal to this. That's why this will give you mod xn of epsilon minus epsilon, this will come. Then again, then what we want to prove is, this again use the coefficient xn minus x less than or equal to mod xn, my xn of epsilon plus mod xn of epsilon minus x. This we got, and this will come from Cauchy sequence by n greater than or equal to n of epsilon. Both will be less than epsilon, 2 epsilon. Instead of epsilon, you can start with epsilon by 2 also, or doesn't matter. Definition itself, a sequence converges to x mean for a given epsilon, there exists a stage, say call it n naught or n of n depends upon epsilon, say that mod xn minus x less than or equal to 100 epsilon for all n greater than or equal to n naught. Will it imply it is a convergent sequence? Yes or no? I am telling the, giving the definition itself like this. I mean, you are equivalent to the original definition. A sequence in R converges to x if and only if for epsilon positive there exists a positive integer n naught, so that mod xn minus x less than or equal to 100 times epsilon for all n greater than or equal to n naught. That implies it is a xn converges to x. Is correct or not correct? See, instead of epsilon positive mean epsilon by 200 also positive only. Then for that new epsilon prime you call it, you would have got mod xn minus x less than epsilon prime by 100 epsilon prime, but epsilon prime is epsilon by 200, then that will be less than epsilon. This fixed constant, that is fixed. That's why many times, most of the time, again will not go to triangle inequality. Convergence mean, okay, mod xn minus x less than or equal to 3 epsilon. Again, less than or equal to doesn't matter. For all n greater than or equal to n naught, that implies convergence. Okay, this is very important because we are talking of everywhere complete metric space. For the main thing is all the examples Professor discussing was on R. So R is complete is very important. That's why I thought better to spend some more time. If you don't answer tomorrow also, then again I will ask. Okay, okay. This one thing. Another one more simple exercise. So we started with, this is not any doubt related to this, okay. So we gave another exercise, x complete metric space T from x to x 0 less than or equal to k less than half case. Say that some name it is a distance between Tx, Ty less than or equal to k time. This also we have used several times, plus distance between x Ty plus y Tx. Then what was that exercise you remember at least? Then prove that there exists alpha greater than 0. We are not talking about the yes under this condition. Again you start with any x naught, Picard's iteration. You can prove the distance between xn plus 1 and xn less than or equal to k times distance between xn minus 1, like that. Similar to Banach. So here what we were trying to give, can you find another alpha positive? This we are telling. Can you find alpha, their x is alpha positive, such that distance between Tx, Ty less than or equal to alpha time distance between, like Kannan type, distance between y, Ty, here only what is the rest, here alpha is not less than half or anything, it is strictly positive. That is why we have seen once this condition is there, if it may have fixed point or not we do not know, but if it has fixed point means that fixed point will be unique. So here also that is a contraction map, that exercise also you can do later. If it is a contraction map also this condition will be satisfied. Kannan case already the statement is like that, alpha equal to less than half. I mean less than half means some less than or equal to some positive constant is there. Here how to get, anyone tried? The only triangle inequality. What, see, this we have already this condition, okay, just to use one more triangle inequality, that is all. This is very standard way we use in many of the results. Trivial, distance between x, what we want, Tx, because triangle inequality we are using mean plus distance between Tx and Ty, that is all. See, all of you know it, plus distance between Ty and y, this we, that is all. What we want is, this we want, this we want, this we do not want, correct? Do not want, or so this we can bring it to the left side. This means what, distance between Tx, Ty into, this comes to this side. Here the k times is there, okay, that is at 1 minus k less than or equal to k times the distance between x Tx and y Ty. Then this will go to 1 minus k, k positive, k in fact less than half in this case, 1 minus k, our alpha is k by 1 minus k. Similar thing for contraction also. So just that's why you should not feel that all difficult exercise. Simple thing, at least please try to do some exercise, then at least tomorrow open session, then better we'll ask some up, come to the board and do some exercise, solve some exercise problem. Okay. Okay, now the remaining, now we will now complete the remaining things from, essentially we have done everything for 2 players, we want to go for n player, but before that some simple example for, we do not require to do any, we are saying upper semi continuous, use very topological fixed point theorem, nothing. Very simple example, that is whether application, whether you have to do know all this proper fixed point theorem, then only for every every game you can solve. We are not saying everything like that. So let us say simple thing, we have 2 player, player 1, what is M is a simple set we take, closed interval 0, 1, this is the set of rules for player 1, or another name is strategy set for player 1. Strategy means we are playing here, which from where you have to select. That is why if you are tossing a coin mean my strategy set is 0, 1. So similarly for chessboard mean all those coins. Similarly we will assume that n also closed interval 0, 1. We will give you a symbol like 2 partner types. Partner 1 will do some work, partner 2 will do some work, then they will combine, and the income, one may be more efficient than the other, that is possible. They may not be equal, So we define, what is this we call f from m cross n to what we call f as, what is the name we gave? Huh? M cross n Cartesian product, okay. The function f is, pardon? Income function, yeah, profit function, or no, they all call it like said payoff function, correct, anything, it's a name, doesn't matter whether you call it income function, profit function or payoff. If it is a loss case, income should become loss, income may be negative, yeah, so again profit can be loss, and that payoff is common, payoff function, okay, that name we know. So what is the meaning of this? F of xy, player 1 selected a strategy x from close interval 0 1, and y, second player selected y from his strategy set, both in this case same strategy set. You can think of the percentage of work. X belongs to close interval 0 1 means the first player, what amount of work he has done. X equal to 0 means what? He has not done anything, type. So that is a hint, let us see. So let us say f of y is more efficient, his income is depends upon this choice. Let us say f of xy equal to x plus, let us say y by 2. That means first player select x, second y, then his income is x plus y by 2, which is a real number. That's all. For us, we know that it is non-negative. What type of function? Now we know it is a nice continuous function, all that. We don't even bother about that. This we teach for school students, just to say what is the equilibrium point without even knowing very advanced level. And G, again from m cross n to R defined as G of xy, is maybe little not that efficient compared to first player, but from his thing he will get, so contribution from here is say x by 100 plus is take y from here. This is the, both are any contradiction. F is payoff function for player 1, G payoff function for player 2. Now you go back our yesterday thing, then what we did? Fix, okay, we fix first x, no? Player 1 selected a strategy set x. From his strategy set, this is what our m. Then what we did? What notation we use? Then here that means the player 1 has selected a strategy x and informed the second player, I have selected x. Today my capacity is only this much. Now you do whatever possible so that you will get the maximum profit. Okay, that's what we did. So what we call that? What is the notation? Pardon? Okay, T1y. That means this is the, if we select y, you will have to get the maximum profit. That means this is set of all, sorry, this notation, first what we write, this is not variable, here it is T1 x is fixed. But if we select y from his strategy set 1, then the profit is Profit is, if key select y, already first player selected x, whose profit will be maximum? Pardon? Player 1 or 2? Player 2, very good, player 2. That means g of first player selected x, this gives the maximum of g of x comma a for all a belongs to 0 comma 1. So now you select what should be the set. What is this? That's it, is not no advanced math or anything. Which will give, which y will give the max? X is fixed. Second player he cannot change the x, but he has the freedom to select which strategy y, he will get the maximum. What is his profit? G of xy is, this is, what is the profit? G of xy is x by 100 plus y. This should be greater than or equal to g of xa, mean x by 100 plus a. So what should be the y? Y, which will give the maximum. He has the freedom to select any element y from closed interval 0, 1. So what will be the maximum? Y equal to 1. So trivial thing, that's what it is, we don't require. So this set will become singleton one. That's why don't think that always it is a set valued map. In particular it can be single valued also. Similarly, what is T2 of y? Same thing. Set of all x in closed 0, 1, say that f of, if we select x, y, this should be greater than or equal to f of a comma y. Again what should be this? Again f of x comma y mean x plus y by 2. That should be greater than or equal to a plus y by 2. That is possible when x equal to pardon? Again 1. So that's it, the maximum is attained. Here no advanced thing. That means in this case, so what is the equilibrium point? 1 comma 1, that's all. Just to illustrate is trivial, not so now don't go to, now you see that all the condition of Kakutani fixed point theorem, so don't go to a expert and this is trivial. In this case that means what? The player 1 select 1, player 2 select also 1, then both will get the maximum profit. So what is the profit for player 1? Here first selected 1, second 1. What is his profit? 1 by 1 plus 1 by 2. And g of 1 comma 1 is 1 plus, need not be same. Okay, so one can give, there are non-trivial example, any of that. Okay, this is just to illustrate. Next thing, as I told, there are some game theory, 2%, even if it is 2%, zero sum, that is 2% zero sum, then what should the relation between f and g? F of xy, g of xy, then they are related. Sum is 0, that's a 2% zero sum came. F of xy plus g of xy is 0. So that type of, we are not interested to do game theory. Our interest is to make you to feel what is Nash equilibrium point and how, what is the role of fixed point theorem. Prover fixed point theorem, or we introduce using Kawakutani, whatever we almost did the proof. Kawakutani's theorem implies under suitable condition Nash equilibrium point exists. See, not only for this problem, under what condition that exists was important. Okay. This one thing. Now we have, let us say players are n player, okay. First you want player n player or 3 player, 2 to 3 or 2 to n, which you are comfortable. Pardon? 2 to 3, very good. So we have, okay, because 3 to n will go now later, so we will call it x1 is instead of m, x1 strategy set or set of rules for player 1, x2 set of rules for player 2, x3 set of rules for player 3, and how many payoff function will be there again? Everyone will have payoff function. So again we call it f1 payoff function. What is the domain? x1 cross x2 cross x3. See, meaning is f1 of x1 comma x2 comma x3. This meaning is player 1 selected x1 from his strategy set x1, second player x2 from capital X2, third player x3 from capital X3, then this will give you a income, profit or payoff. So this is a function to R. Similarly, J varies from 1 to 3. We have 3 payoff function.
That is also called objective.
Pardon?
Objective function.
Is a payoff function. Okay. It doesn't matter. Whatever you like, you can call what. Name doesn't matter. That's why they call it profit or payoff. That name doesn't matter. I may not be knowing all the names. That, yeah. Again, like there what the player 1 announced, I have selected a strategy. Then he informed the player 2, now you select whatever you like, so that your profit is maximum. He should not know, I don't bother maximum or minimum, I will select any. Then he is not in the game. Understanding it, he will have to select a strategy which gives the maximum profit to him. So what should be, so let us say player 1, if you want from x3 to x2 x3 or x1 x2 x3, x1 x2 x3. So first player selected x1 from capital X1, and he will inform whom? Both player. He will inform the second player also, third player also. Then that case both will have to select the maximum. So one will see. Then what will be? There we used, that's why here better to use the notation T2 of x1, this corresponding to second player. What he will select? Select a strategy x2, sorry, yeah, here the freedom is, in fact I am, so not only this will not help, he will give the freedom at a time to one player, not freedom to one person selected and informing the two. What they inform is, at a time 3 are there, mean first and second will select, inform the third, second and third select, inform the first. At a time one person has the freedom to everyone will get a choice. I mean, I will get a one first player, first we have x1 belongs to x1, x2 belongs to x2. They have both x1 has selected. See, they at the time, first manufacturing unit, we are going to manufacture this x1 unit. Second unit say x2, informing the third unit. Now you manufacture so that your profit is maximum. So, okay, here doesn't matter. Now we can use even T1. T1 of what now? X1 comma x2, because both are x1 comma then same thing, equal to set of all x3 or notation doesn't matter, x3 from his strategy set, x3 belongs to x3, so that this profit, that means what is his function? F3 for third player, but already first player has selected x2, second player selected x2, first x1, second x2, third if he select x3, that should be the maximum, meaning is f3 of x1, x2, this third player don't have any choice, and here only A for all A from his strategy set. So like that. So similarly we will define T2 means x1 comma x3, T3 of x1 comma x2. Then like there we will define, at least if you under any doubt, pardon? Second time. T3 here x1, one x1 is now correct, na? X1, x2, third player, here second player, here is the second and third. Oh, let us see, second and third, so that first player, here first player, here second player, here third player, first, second, third, you wait, check, okay. So we have this, so all the similar way we define, then we will define a map from x1 cross x2 cross x3 to that same set x1, that will be multivalued map similar to that in a natural way, again like that time. It is a multivalued map. For example, this is a subset of, one is subset of x1, subset of x1 plus subset of x2 cross subset of x3. Then again that will be a subset of x1 cross x2 x3. Then again we will get a point, say x, y, z belongs to that T, that fixed point will give the maximum profit. If you have n player, same idea, then that case x1, x2, xn minus 1 player will select, inform the nth player. Then at a time one, n minus 1 player will select, then inform the third. See, once, that's what many times while teaching also, immediately don't go for very abstract. Start with symbol, go to the next step, student level understanding abstract, that's why in the even f from closed AB to closed AB continuous function, it has a fixed point, exactly same idea. But if we write f from closed 01 to closed 01, immediately you feel f of 0 not 0 and f of 0 belongs to closed 01 means you feel f of 0 greater than 0 clear, and f1 not equal to 1, f of 1 belongs to closed interval 01 means f1 less than 1. Then it is immediate, gx equal to fx minus x, then g of 0 to g of 1 is negative, then immediate intermediate. Then tell that yes, same idea, then explain closed AB, that will be easier. Okay. Yeah, maybe tomorrow again what we started in Today also Professor Berende is, with that I will stop, just